Thanks for having me. I'm really happy to be part of this summit. I think it's a great event that is bringing a lot of valuable information to simmer at the end of it. So for the passionate ones who have been with us since the beginning, I know it's getting late for most of you, so please do a few shoulder rolls or dance move as you wish. Stick with us. There's only a few sessions left. So I hope you still have some energy to listen to me. So as the electronic manufacturing landscape evolves, data-driven decision-making and real-time process control have become essential for competitiveness and quality in PCBA production. I guess some of you have heard about tariffs, about the challenges with the global economy. So this is getting even more important now to improve our PCBA productivity and also reduce cost. So in this session, I will cover with you the connectivity challenges between machines and system in SMT manufacturing, the different strategies for capturing meaningful data, and also the best practices for shop floor control and active traceability. So I hope that today's discussion will equip you with practical approaches for breaking down silos, achieving true shop floor transparency, and empowering your teams to make faster and smarter decisions. The story of enhancing PCBA manufacturing and shop floor control all starts with data. It's really the key to unlock process optimization. So we're going to talk about decoding the data silos. So all machines you have on your SMT floor are already generating and collecting data, but are often trapped within the vendor software platform. You might have a line with ASM machine, a line with Panasonic machines, and all of this data is kept whether in OIB or Panasim. And when you have multiple vendors, the data is typically never connected together. They don't always make it simple to send the data in an open format, and it's not easy to pull together all the different elements from the many vendors on the shop floor. I would wager guess that you have at least 5 to 6 vendors in one line, and it's just one line. You probably have more than that line, and juggling the different platforms to try and get a complete picture of what's happening on the line is difficult, to say the least. So trapped data can definitely lead to quality issues. Without a single source of truth, it's challenging to ensure the accuracy and completeness of data, which can affect product quality and compliance with standards. In addition, when the data is not shared between teams, it can hinder collaboration and continuous improvement efforts. Problems may not be communicated effectively or communicated at all, and opportunities for process improvements or innovation can absolutely be missed. And when the data is trapped in the different vendor platforms and not visible across the entire line and organization, too much time is wasted in manual data retrieval or reentry, which slows down production. When you are gathering all this data, everything will be fed automatically. So it really limits the amount of manual data entry. And not having the big picture can lead to delayed decision-making and the ability to respond quickly to issues on the line. You can target specific improvements without the full picture. Plus, as your manufacturing operation grows and new technologies or machines are integrated, data silos can become a huge obstacle. The lack of integration and interaction between system can definitely limit the ability to expand or update the manufacturing process seamlessly. Factory digitalization is actually more complicated in electronic manufacturing than other manufacturing verticals, as there is no set standard or protocol governing all machines and systems. So when you think about semiconductor manufacturing, you can think about 6Gen, but with SMT manufacturing, there's been a headway with CFX in general. There's still an enormous install base with different types of machine, protocols, and formats. So while significant progress has been made in machine integration, we'll still come up against the persistence of data silos across the manufacturing ecosystem. So that means that each machine needs some kind of adapter tools to help extract and normalize data from the shop floor, because every machine will have different ways to communicate the information. Could be in a text file, and when we talk about text files, there's so many different formats. Can be a CSV, it can be a XML or a JSON file, could be shared with a proprietary format in a database, and there's all the different communication protocols as well that are involved. So that's really challenging, and domain expertise is critical. So using an off-the-shelf solution offering circuit board assembly expertise is a great way to overcome data connection and enable contextualization. So Cogiscan has been doing machine connectivity for over 20 years, specifically for SMT manufacturing, bringing that rich granular data on the shop floor and feeding that data to the rest of the ecosystem. With the Connect platform, you can tap into multiple data sources. The data is then enriched into a common format, and it comes built in with over 200 machine adapters, but also include a no-code platform that you can use to build adapters with custom machine, for example, with testers. So with Connect, obviously you can connect to the machine and collect the data from the entire production ecosystem. The value resides in PCBA manufacturing specialization, enriching data into a comprehensive and SMT production-oriented format. So the data is taken and contextualized by bringing shop floor control data, such as the work order information or consumption, into the equation. You can get really specific information about your pick and places. So you can know if you had mispick or drop components, from which feeder it came, from which head, nozzle, spindler you had the issue with, and all this data is available, and you just have to tap to it to know it. So all of this data that we can take is then transformed into traceability or visualization with actionable insights. All of this rich information can be shared with other systems to enable other functionalities, such as quantity tracking in your ERP, for example. So you can share this information via REST API, via different brokers, such as RabbitMQ for AMQ Pay or MQTT. So it's really flexible. And the key here is that you have to share this data with the different systems. Now, all that data is key for material management, and I'd like to cover the importance of having a shop floor solution that covers and understands all the nuances in PCBA manufacturing. Effective material control will save you money, and knowing that over than 75% of the cost of this PCBA is from components, you definitely want to have effective material control. And for that, you need accuracy. So accuracy in the storage location, Accuracy in the remaining quantity, so that you know everything about your inventory. So by having each reel, tray, stick uniquely identified, you will have precise information that are not typically available in an ERP. So as you see in this slide, in the ERP, you will have information such as the material part number, the overall quantity, and the overall location. So you know that this part number is into the warehouse. But when you want to get it, it might be challenging because the warehouse can be big. So where is it in the warehouse? So you need to have precise information to be able to find quickly the parts that you need, because you want to reduce downtime. So with effective kitting and job setup, for a specific part number, you will know how many reel you have, what's their remaining quantity, and where they are. So you don't have to run around and just look for the reels. And all this information is key for proper job setup. Production management, such as having low-level alerts on the line before a reel gets empty. So you really need to get all the details about what you have in stock. Data synchronization with a closed-loop inventory management system plays a key role in optimizing the SMT process. So as an example, we have the material initialize and manage an ITAC, meaning that unique IDs are created and information such as quarantine material will be managed there. And we have this closed-loop quantity synchronization between MES system and across. As components are used on the production floor, usage data is being fed to us for updating inventory levels. This process also includes synchronization with SMT towers and X-ray counters, providing a comprehensive view of inventory. The benefit here is real-time accuracy, ensuring that inventory data is always current and reflective of the actual stock levels, which minimize stockouts and overstock situation. And operators are being notified when a low level happens on the line. So your water spider, for example, would know exactly from which tower they can get the reel. And with this process, it reduces line downtime in the factory and reduces as well unnecessary operator movement, because we need to optimize everything. A key aspect of material management is sensitive material management, especially in high reliability PCBA manufacturing. Effective management of MSD in electronic production is a complex and multifaceted challenge. Preventing moisture-related failures requires strict adherence to a range of rules and processes across the entire life cycle of these components, from the moment they are received and labeled, through storage, exposure, baking, and assembly. So given the number of variables involved and the high cost of errors, it's not realistic to expect effective control using paper-based logbooks or spreadsheet trackers alone. Kojiscan offers a purpose-built MSD control platform designed specifically to meet these needs. And funny story, it was the first product we released to the market over 25 years ago. It provides comprehensive tracking and control for every stage of the MSD handling process, ensuring that the right rules are enforced automatically and consistently without relying on manual intervention. The advantage of using such a platform is the visibility across all the different machines need for MSD management and control for their different processes. So it will cover all the rules from storage, baking, and even placement. It manages as well rules such as the minimum remaining exposure time before moving further down the process. And interlock points can be added anywhere with the help of a product flow controller with machine communication. So for those of you who don't know what is a product flow controller, it's a device that Kujiscan has that you can connect to your conveyors using the SMIMA protocol, and it will stop the conveyor to prevent the board entering the machine if it shouldn't. So with interlock, the process could be stopped in front of the pick and place or reflow oven, for example, so that the product is not built if something is expired on it or if the minimum remaining exposure time is not met. Sorry. So data and a proper material tracking are the key for active traceability and control. In this section, we're focusing on how to guarantee quality at every step of the SMT process. One key aspect is the ability to validate and control critical elements throughout the entire SMT manufacturing line in real time. So for example, the line can interlock, the system can interlock the line, essentially stopping production if it detects that the MSD has expired or even is close to expiring. This prevents potential reliability issues further down the line. We also guard against misloads. If the wrong materials or an incorrect programs are mistakenly loaded into a machine, the process can be halted immediately, preventing costly rework and scrap. Another control point ensures that each assembly follows its required process steps. So if an upstream operation is skipped, the line won't proceed until the issue is resolved. All of these controls feed into comprehensive traceability, active traceability, meaning every detail is captured and reported. This is invaluable for process improvement, for compliance, and customer reporting, because you have a complete holistic view of each product's manufacturing history and quality status. And ultimately, these measures don't just catch errors. They create a culture for proactive quality management where issues are prevented, not just detected after the fact. And I believe that's something you really want to have in your factory. So my message here is don't wait at the inspection before finding out that something is wrong. With the different elements of line control, you can prevent errors from happening. So from making sure materials and components are used under the right conditions, you prevent ahead of time that defective and expired materials are to be used in your factory operation. So with LCR control, you can verify that the electrical characteristic of components are accurate so that you can act if it's not, and make sure you don't use them. Time-sensitive material can be used to track thawing and expiration time for consumables such as solder paste, ensuring that the consumables can safely be used for production, following the manufacturer's recommendation. You can interlock production in the case material is expired. And one thing that you always want to reduce is the job setup time. You want to make sure your machines are producing at full capacity all the time. Kitting control is a great addition to your process, as you can prepare ahead of time future jobs to minimize the setup time. Whether you are using a closed-loop integration with a tower or not, operators can prepare kits by efficiently getting the parts. They can get them from a storage location, from a SMT towers. You're ready to run production, but you want to make sure your machines are properly set up for the boards waiting at the machine. With setup validation, you validate every element from machine program to component and location of the machine. If something's not right, it won't go into the machine. With route control, you will avoid manufacturing errors, meaning that a machine will interlock if you are trying to process a defective board or if a production step has been skipped. All of this control can be enabled independently of each other so that you can target specific process improvement to eliminate potential defect. And you just have to pick somewhere where you want to start. And then you can one by one enable all these different processes to ultimately have a fully defect prevention setup. To wrap up, we've explored how enhancing data management and control on the shop floor can improve quality, traceability, and efficiency in PCBA manufacturing. I really encourage you to consider how these approaches can be applied or elevated in your own manufacturing environment. So thank you for being with me today. We have some time for questions, and if you like more information or wish to discuss specific needs in greater details, don't hesitate to reach out to me.
All right. Thank you, Julie. Thank you for the presentation. We do have some time for questions, and we have a few questions from the audience. First one is, are your solutions specific to PCBA manufacturing, or can they be used in different manufacturing industries? If yes, do you have use cases?
Our expertise is really with PCBA manufacturing. We know everything about the SMT process and backend operations. So that's really our focus. The Connect platform, if you want to get data from your equipment and you are not running PCBA manufacturing, the Connect platform has the flexibility for you to create your own adapters to get the data. But that's not something that is typically done by us. So.
Okay. Second question is, we do not have machine connectivity at the moment. Is it something that can be done in-house, or what should be the first step?
So the short answer is yes, you can do it in-house. But there's a lot of challenges with machine connectivity. As I said, there's different standards that are present on the market. There's machine upgrades that will come up. So that means that you will have to update your connectivity solution maybe every time a machine gets updated or you get new equipment from new vendors. So a lot of our customers and people I've talked to have tried to do it by themselves. But at the end of the day, it was really challenging. You have to have knowledgeable resource in-house, dedicated resource that will be able to focus on connectivity. But then you always have to be up to date on the different standards, and you need to basically be a specialist in every standard. So yes, you can do it, but there's a lot of challenge that comes with it. And that's why we suggest to use an off-the-shelf solution.
Mm-hmm. Thank you for your answer. We do have a last question for you. Can quality management and repairs be tracked with your solution?
Yes, definitely. That's a part I didn't cover in the presentation. So the first step is always to connect to the machine. So from the AOI, from the SPI, AXI, we get a lot of rich information. We can get the defects, the component part number on which they were found, the reference designators. So that way you can, you know where the defects are, and also you can build the analytics and KPIs based on the defects you are finding. We also have a defect management module into our track, trace, and control platform in which you can proceed with manual inspection, but also rework. So if you need some rework to be done, we have a visual task that would allow you to, by loading the board's design, you see the different defects that you need to rework. So that can be added in addition to all the other modules you might be using.
Mm-hmm. Let's see if we have some more question. No, it doesn't appear so. So I would say thank you, Julie. Thank you for your presentation.